Salam. Today, we will be doing the exercise of Chapter 3, Class 11 Statistics, according to PTB syllabus. First of all, have a look at the index. The answers to all the questions are available to you on my channel. Please do watch for better understanding. Note, questions 3.29, 3.31 and 32 are available as short videos. Here let's start with question 3.2. Find the geometric mean of 50, 67, 39, 40, 36, 60, 54, 45. For that, we form a table of all these values and take the log of each of them and then add them. The formula of GM is antilog 1 over n sigma log y. So we take the antilog of 13.4384, which is the total of log y divided by n, which is 8, so the answer is 47.841. Question 3.3. A man traveling 100 kilometers has 5 stages, at equal intervals. The speed of the man in the various stages was observed to be 10, 16, 20, 14, 15 kilometers. Find the average speed at which the man travels. Statistics is all about creating tables, so here we converted this data into a tabular form. Here, according to the data, we need to calculate the harmonic mean, so which take the 1 over data y. You might ask why harmonic mean? HM is used to calculate average speed, specifically when a journey is divided into equal distance intervals. Then, we add all the 1 over y's. Use the harmonic mean formula, put in all the values as 5 over 0.352 and thus we get the answer 14.2045. You can also use the arithmetic mean also to find the estimate average speed of the man, which is 15 km. Next is question 3.4. Calculate mean, median and mode for table 2.5 that is available in your book. First we extract the number of rotten potatoes as y, the frequency from this table, that we need to find the mean. We add column free and multiply each y to the corresponding frequency f. The summation of f is 20 and free is 30. The mean is summation free over summation f, which is equal to 30 over 20, and the answer is 1.5. For median, we first need to locate the observation. For that, we use n plus 1 over 2, which equals 20 plus 1 over 2. So we get 10 and 11th observation, which is here. So we automatically know that the median is 1. And similarly, since 1 as has the most frequency, so it is the mode also. Next is 3.5, which is quite similar to the previous question. Here, we also need to calculate the mean, median, and mode for this table. First of all, we extract class and frequency column from it. Since we can't take the mean using continuous classes, we need to find the midpoints as a solid discrete number. For that we add the lower limit 2 and upper limit 4 and divide it by 2. We do the same for all the classes, and this is what we will get. Then we can multiply f and x. Now we can find the mean using the formula summation fx over summation f. We calculate the sums of these columns and place the values here as 609 over 51, which is equal to 11.94. Next, to find the median, we find the location first using n over 2, which equals to total frequency 51 divided by 2 equals to 25.5th observation. Here we have create another column of cumulative frequency, so now we know that this contains the 25.5th observation. Here we use the median formula for grouped data. L is the lower limit of that class, which is 8 plus width of the class 4 over frequency 12 brackets. The observation 25.5 minus the previous cumulative frequency, which is 15. Calculate everything and then get the answer 11.5. Now finding the mode. The value with the highest frequency is 14. We use this formula of mode. So mode equals the lower limit 12 plus brackets fm, that is 14 minus f1, that is 12 over 14 minus 12 plus fm 14 minus f2, 6, that comes after the concerned class, multiplied by the width of the class, which is 4. We first solve the items in the brackets and thus get the answer 12.8. Moving on to question 3.6. Calculate the following for the data of exercise 2.8 part B, part 1. Calculate the estimate for the mean leaf length. And then, construct the cumulative frequency table and use it to estimate the sample mean. First of all, we need to calculate the mean leaf length. Here we need to multiply x with its corresponding fx and then taking the sum of the frequency as well as fx. Now use the mean formula and place all the values in it, as here the answer is 4.405. Next is part 2, where we first need to construct the cumulative frequency table and then find the estimate sample mean. Here's you can see we have added the CF column where we add all the frequencies as so. These are the values of cumulative frequency. Here we find the observation where the mean is present. For that we do n divided by 2, which equals to 100 over 2, that is the 50th observation. And according to our cumulative frequency, the 50th observation tends to lie here. Thus the estimated mean is the corresponding x value, that is 4.7, which is the answer. Next is question 3.9. The answer to its part 1 is given in lecture 3.7. Go check that out. Here we are going to do part 2. For a certain frequency distribution, with the mean and median 45 and 36, respectively, find the mode approximately using the empirical relation between the three. So, here mean is 45 and median is 36. We need to find the empirical relationship between the mean, median and mode. For that, as we have learnt in lecture 3.7, the appropriate formula is mode equals to 3 median minus 2 mean. Put the values of mean and median, multiply and calculate. Thus the answer is 18. Here as we can see, mean has the greatest value in mode as the smallest, so it shows that this relation is positively skewed distribution. Question 3.10. Bilal gets a rise of 10% in salary at the end of his first year of service and further rise of 20% and 25% at the end of the second and third year respectively. The rise in each case being calculated on his salary at the beginning of the year. To what annual percentage increase is this equivalent? First, let his initial salary be 100 rupees or dollars, you name it. Then we know his increment in the first, second and third year. Increment in the first year is 10%, so his salary would increase by 10 rupees, making it 110. In the second year, 20%, so his salary would be 120. And in year 3 increment is 25% of the original salary, making it 125 rupees. As percentage is involved, we use geometric mean. And the formula is this. Gm equals y1 multiply y2 till yn all raised to the power 1 over n. Here as there are 3 observations only, so Gm equals to 110 multiply 120 multiply 125 all raised to the power 1 over 3. Use a calculator to solve this and you'll get the answer 118.17. Here if we need the answer in percentage, we need to add another step. We subtract 118.17 from 100, so the answer is 18.17%. That's it. Question 3.11. Find the mean for the following distribution. First, we will verticalize the table. Now you tell me, how will we find the mean with only continuous classes? That's right. We need to find the midpoints of these classes, so that finding the mean is possible. For calculating the midpoints, we add the upper and lower limit of the class and divide it by 2, like 0 plus 10 divided by 2, and this will be the outcome. Now we can find fx by multiplying the midpoint x and frequency f, TDAA. Now we just need to take the summation of frequency and fx is here, as the formula of mean says summation fx over summation. It equals to 49,975 over 670, which is equal to 74.59. Now, be attentive for question 3.12. First I advise you to recap lecture 3.2 for better understanding. Now what is the question? The frequency distribution has been obtained using the working origin. If d is equal to x minus 18, find m and gm. Now, first, multiply each variable d by its corresponding frequency and then take the summations. Here we are using the shortcut method of the arithmetic mean. The formula is am equals to a plus summation fd over summation f. Here, only the arbitrary value that is added into the original formula. The a here is 18. See 18 plus 256 over 80, thus the answer is 21.2. Now before explaining any further, we need to make sure that we understand what is d equals to x minus 18. D is the derivative of each data point. X is the midpoint, and 18 as said earlier, is the arbitrary value. Now, our main focus is find the value of x, the midpoint. For that we take the 18 to left hand side and x remains here. That's it. We needed this equation. We add a column of x in the table and calculate all the midpoints by putting the values of d in each row. Like in the first row, minus 12 minus 18 equals to 6. Here we now have the midpoints. So obviously it's much easier for us to calculate the geometric mean. For that, we find the log x, so go and grab your calculators and perform like this. Log 6 equals to 0.77815, etc. We just need max 4 digits after the decimal point. Next we multiply each corresponding frequency by log x, and approximately this will be the total. 104.19. The formula for GM is antilog summation f log x over summation f, placing in the summation values and that its antilog. Thus the answer is 20.06. Next question, 3.13. The reciprocal of 11 values of x are given here. Calculate the harmonic mean and the arithmetic mean. Here, note here the reciprocal, i.e. 1 over x is already given. That is very helpful finding the harmonic mean. So, first we will add all these values as a summation 1 over x, that is equal to 0.3093. Using the simple hum formula, we place in the values 11 over 0.3093. Thus the answer is 35.56. Now, for finding the arithmetic mean, we need to reciprocate the reciprocal of these values to get the original values of x. For that we use this formula. Now we take the summation and use the formula summation x over n, the number of values, which equals to 463 divided by 11. Thus the answer of arithmetic mean is 42.1. Next is question 3.14. It's exactly the same as 3.13. Here we just need to calculate the harmonic mean. And we already have the reciprocals of the values of x. Take the summation of all the data, that is 0.1386. Use the hum formula. Place in the values. There are 7 total values divided by summation 1 over x, 0.1386. That results in 50.505. Moving on to question 3.15. 3 cities A, B, C are equidistant from each other. Fatima travels from A to B at the speed of 30 miles per hour by car. From B to C, speed of 50 miles per hour. Determine her average speed for the entire trip. Here we can comprehend that 3 cities A, B and C are at an equal distance. The speed from A to B is 30 miles per hour. And speed from B to C is 50 miles per hour. The formula of simple harmonic mean is n over sigma 1 over x. Here, there are two n, two speeds. X and dx are the speeds 30 and 50. Step 1. Find the reciprocals. 1 over 30 plus 1 over 50 is equal to 8 over 150. Step 2. Apply formula of the harmonic mean, 2 divided by 8 over 150. For that, we multiply 2 by 150 over 8. That equals to 300 over 8. Thus 37.5 miles per hour is the answer. Remember, when distance is same, always use harmonic mean, not simple arithmetic average. Hope you got it. Next is question 3.16. Harmonic mean and geometric mean of two numbers are 3.2 and 4, respectively. Find their arithmetic mean and both the numbers as well. So here we know that HM equals to 3.2 and GM is 4. Now, let A and B be two numbers. Now let's come to deal with the hum and GM separately. First, the harmonic mean. As we know the answer of HM, we place the 3.2 at the left hand side of the equation. And the formula to calculate it on the right side. 1 over A plus 1 over B can be combined as A plus B over AB. And now, according to the rules of maths, we can multiply AB with the numerator too. That is equal to AB over A plus B. Now, let's keep it aside and deal with GM equals to 4. So 4 is the left hand side, and its formula square root of A multiplied by B, squaring both sides. We get 4 square equals to square root A multiplied by B whole squared. That is equal to 16 equals A multiplied by B. The whole square cancels the square root, that's we get the simple A multiply B. Now, did you notice something interesting? As we got the answer of A B 16, we can easily place its value in the harmonic mean formula. So we do that. 3.2 equals 2 multiplied by 16 over A plus B. Now, can cross multiply both sides is get this. So now our mission is to find A plus B, so that is equal to 32 over the 3.2, which is equal to 10. Okay, so we have got the equations, A plus B equals to 10 and AB equals to 6. We know that A minus B whole squared equals to A plus B whole squared minus 4AB in this formula. we put in the given values of a plus b and ab, and get 36, then we to square root it, to get rid of the square on a minus b. So, a minus b equals to square root 36, thus plus or minus 6 is its answer. Now, we know that a plus b equals 10 and a minus b equals plus minus 6. So now, we deal with the plus and minus separately. We add both these equations, one with a minus b equals minus 6 and the other with plus 6. First, see the left side. Here, a and a adds into 2a. Plus b and minus b cancels each other, and when adding 10 minus 6 we get 4. So we have 2a equals 4. WHWN we simplify it, we get a equals to 8. On the right side we perform the exact same steps and get the answer. A equals to 8. Now putting the values of a in one of the above equations. I choose a plus b equals to 10. So on the left side of your screen we have equals to 2. When we put the 2 into the equation we get b as 8, and on the other side b equals to 2. Now, finally we find the arithmetic mean. We can use any of the two cases where a equals to 2 or a equals to 8. So m is equal to 2 plus 8 over 2, thus the answer is 5. Ah, what a lengthy question. Next is question 3.17. The arithmetic mean and geometric mean of three numbers are 34 and 18, respectively. Find all the three numbers when the geometric mean of the first two numbers is 9. Here this is the data we collect. M equals to 34, GM equals to 18 and GM of the first two numbers is 9. Let A, B and C be three numbers. And deal each of these means separately. The formula of M is A plus B plus C over 3 equals to 34. Multiply the denominator of the left side with the numerator on the right side. Thus, A plus B plus C equals 102. Label it as equation 1. Now the geometric mean of three values is calculated like this. The formula of GM, cube root ABC, that is equal to 18, cubing both sides to get rid of the cube root, and thus we get ABC equals 5832, labeled as equation 2. And lastly, geometric mean of two values is calculated as this. Square root B is equal to 9. Squaring both sides to get rid of the root, as we get AB equals 81 as equation 3. So, now we know the value of AB. So we can put it into the second equation. 81 multiplied by C equals to 5832. To get the value of C we divide 5832 by 81, and thus get C equals to 72. And as we know the value of C we can put it in equation 1 and get the value of A plus B as 30. Okay. We know that A minus B whole squared is equal to A plus B whole squared minus 4AB, so we can put in the required values. So 30 squared equals to 900 minus 4 multiplied by 81, that is 324. So 900 minus 324 is 576. To get rid of the square we square root it and get the answer 24. Now, we can simply add the A plus B equals to 30 and A minus B equals to 24 equations. So we get 2A equals to 54, and thus the value of A is 27. Lastly, to find the value of B, we put A equals to 27 in this equation. A plus B equals to 30. So B equals 30 minus the 27, and thus 3 is the answer. So, A, B and C are 27, 3 and 72 respectively. Question 3.18. Find out. Part 1. The average rate of motion in the case of a person who rides the first ride at the rate of 10 miles per hour, the next mile at the rate of 8 miles per hour, or the third at the rate of 6 miles per hour. As here the rate of motion is mentioned, that means the average we will be taking is the harmonic mean. For that, value of y is 10, 8 and 8 miles. Then take the reciprocal of it and we will get 0.1, 0.125 and 0.16 respectively. Take the summation of it, which is equal to 0.385. Now, using the simple harmonic mean formula, putting in the values. Number of observations 3 over the reciprocal of y 0.385. Thus the answer is 7.792. Moving on to part 2. Increase in population, which in the first decade has increased 20%, in the next 25% and in the third 4%. First let the population in the first decade be 100. Now, we know that population increased in first decade is 20%, in second decade is 25% and population increased in third decade is 4%. Now, we can convert the percentage into the numerical form. In first decade, 100 plus 20 equals to 120, in second decade, 100 plus 25 is equal to 125. And population in third decade will be 104. So we take the geometric mean of it 120 multiply 125 multiply 104, all raised to the power 1 over 3. Then calculate it using a calculator. We get the answer 115.98 as the geometric mean of the population. Next is question 3.19. The given table knows the distribution of the maximum loads in short tons supported by certain cables produced by a company. Determine mean, median, and mode. Okay. First, as with continuous classes, we can't find the mean. So we take the midpoints of the classes in this data. For that we add the lower limit 9.3 and upper limit 9.7 divided by 2. So it equals to 9.2. And we perform the same for all the classes. Then, we multiply each midpoint with its corresponding frequency. After that we add the summation of frequency and the fx. So, now we can find the mean of this grouped data. 665.5 over 60 is equal IO 11.1. Now, for median, we need the cumulative frequency. For that we add all the preceding frequencies. This is how it would look like. Now, we first locate the median. It is the n over 2th value which is equal to 60 over 2, that is the 30th observation. And according to the cumulative frequency it lies here. Now we take the class boundary of that particular class by subtracting 0.5 from the lower class and adding 0.5 in the upper class. To the class boundary is 10.75 to 11.25. From here we take the 10.75 as lower limit in the median. For h, we need the width of that class. 11.25 minus 10.75, that is equal to 0.5. So plus 0.5 over the frequency 17 brackets n over 2 is 30 minus c. What is c, you ask? It is the cumulative frequency preceding of the median class, which is 19. So, calculating all, the answer is 11.36. Now, finding the mode. We find the largest frequency that is the same class as the median class. So now, we use the mode formula for grouped data. L is the lower class boundary 10.75 plus. FM 17 minus F1 8 do over 17 minus 12 plus 17 minus 14. Here FM is the frequency of the mode class. F1 is its preceding class and F2 is the frequency of the class after it. The H is 0.5 as we know. Hence calculating all we get the answer 11.06. Moving on to question 3.20. Compute mean, median, mode, 6th decile, and 74th percentile for the data given in the table. First comes first finding the midpoint x. After that we multiply the midpoints with its corresponding frequency. Then we take the summation of frequency f and fx. Now, we can easily find the mean by placing the values into the formula. So that answer is 0.7317. Now, for median, we need the cumulative frequency. Here, we need locate the median class. N over 2th is 55th observation. Here, this is the cumulative frequency which will include the 55th observation. Now, we take the class boundary of the median class, that is 0.73175 to upper limit 0.73195. Here, L is the lower boundary 0.73175. The H is the width of the median class. For that we subtract the upper boundary and the lower class boundary, which is 0.0002. So the H is divided by its frequency 25, brackets n over 2, as we know is 55th observation minus the preceding cumulative frequency 45. Thus the answer is 0.73183. Now, for mode, we find the highest frequency, which is 30, so we take the class boundary of this class as 0.73195 to 0.73215. Next, we place the values into the mode formula. L, the lower boundary is 0.73195 plus brackets, FM 30 minus F1 purchase the preceding value. Over 30 minus 25 plus 30 minus F2 8, multiplied by its width h, which is 0.0002. So finally we get the answer 0.7319. Now, for 6th decile, we find the 6n over 10th observation as the locate of the decile class. That is the 66th observation. Thus where the cumulative frequency is 70 is our 6th decile class. As the 66th observation also lies in this class. Okay, so find the class boundary by subtracting 0.00005 on lower class limit and adding that in the upper limit. So we get 0.73175 to 0.73195 as the class boundary. Here, as we have studied earlier, we use the 6th decile formula and placing in the values. L is the lower class boundary, that is 0.73175 plus the h width, which is 0.0002 over f, the frequency of the required class, that is 25 bracket 6n over 10, which is the 66th observation, minus preceding cumulative frequency, that is 45. Calculating all, we get 0.731918 as the answer. Now, lastly finding the 74th percentile. For that we take the 74n over 100th observation. That equals to 74 multiplied by the total frequency 110 over the 100. So we get the 81.4th observation, which lies in this class of the table. So till now, we already know how to find the median, quartile, decile, and thus the percentile is also solved the same way. Have a look at that. We simply put in the required values in the 74th percentile formula. For that we find the class boundary of that class, the width, the frequency, the location of the observation as we know, and its previous cumulative frequency. And boom, we get the answer 0.732026. Note, we can simply write the answer up to 4 decimal places. Next question, 3.21. Find the value of quartile 3, decile 5, percentile 5 and the mode of this, the dataset. So, first of all, the most important column to find all this. That is the cumulative frequency column. In that we add all the preceding frequencies into the next rows, which will look something like this. Now we will just sum all the frequencies f, that is 76, plus. This also helps us to verify that the cumulative frequency is also correct. How, you ask? The last row of cumulative frequency is equal to the total frequency. That is, this case is 76, easy. Okay, now first we need to find the position of third quartile. 3n over 4th observation is 57, so, in the table where the cumulative frequency is 68, the observation 57 also lies. Then we find the class boundary of this class to get the most accurate answers. For that we subtract 0.05 from the lower limit and add 0.05 in the upper limit. Thus the class boundary is 29.95 to 34.95. We only need the lower class boundary as L in the quartile formula. HISTHE width, which is calculated as 34.95 minus 29.95, that is 5. So plus 5 over the frequency 13 brackets 3n over 4, that is 57 minus the preceding cumulative frequency 55. Calculate it yourself, and you will get the answer 30.72. Next, for 5th decile, we first find the location, that is the 38th observation. And it will lie in the 42th CF. Now, just put in the values required in the D5 formula. L is the lower class boundary, which is 19.95, H as we know, is 5 and frequency of this class is 15, brackets 5n over 10. The position of the 5th decile, that is 38 minus the previous CF, which is 27, thus we get the answer 23.61. Next is the 5th percentile. It is found in the same pattern as the quartile and decile. First find the position of the required percentile, that is 5th percentile, which is the 3.8th observation. Look at the table in the cumulative frequency column, find the row in which the 3.8th observation lies, which is not 3 but the row with the 7th observation. Why? Because 3.8 is greater than 3, so it lies in the greater observation category. Okay, then take the class boundary of that class. We need the lower class boundary 4.95 and put it in the formula. Plus h, the width, which is 5, over the frequency, which is 4 brackets 3.8 minus the preceding cumulative frequency, which is 3, and thus we get the answer 5.95. Now, for the mode, we first find the class with the highest frequency. Here it is frequency 15. Apply the mode for grouped data formula. We know the class boundary and the width h, thus we just place in the values. L is the lower class boundary 19.95. Plus brackets, FM 15 minus F1 the preceding frequency 11 over 15 minus 11 plus 15 minus F2 the frequency after the modal class which is 13. Multiplied by the width is 5. Calculate everything. And the answer will be 23.28. I hope you understood these topics well now. Now, moving on to question 3.22. If for any frequency distribution the mean is 45 and the median is 30. Find the mode approximately, using the formula connecting the three. Okay, so we know that mean is 45 and median is 30. What's the formula that connects the mean, median and mode together? Yes, you guessed it right. It is the empirical formula. As we need to find the mode, we use this formula mode equals 3 median minus 2 mean. Place in the values of mean and median. 3 multiplied by 30 minus 2 multiplied 45 is equal to 0. Here, as we know, the mean is greater than the median and mode, so we know that this relation is positively skewed. Question 3.23. A bus traveling 200 miles has 10 stages at equal intervals. The speed of the bus in the various stages was observed to be 10, 15, 20, 75, 20, 30, 40, 50, 30, 40 miles. Find the average speed at which the bus has traveled. Here, as we know that there are 10 equal intervals, the average we need to find is the harmonic mean. First, convert the data into a tabular form. We know the speed y in the 10 stages. Then for the harmonic mean, we need to find the reciprocal of each speed. And name this row 1 over y. Next we summation the reciprocal of y, that is 0.4166. Thus apply the HM formula. HM equals to know of values 10 over sigma 1 over y, that is 0.4166. So the answer is 24 miles per hour. Now, be attentive for question 3.24. The following data has been obtained from a frequency distribution of a continuous variable x after making the substitution u equals x minus 136.5 over 6. Find the harmonic mean. Okay, first focus on this for a minute. U equals x minus 136.5 over 6. Here u is the substituted value and x is the midpoint. So, we need to derive the equation of midpoint from this. For that, we cross-multiply the two sides. And so 6 multiplies u, which is equal to x minus 136.5. Then we take the minus 136.5 to the other side, and thus the equation becomes 6u plus 136.5. Which equals to x, the midpoint. So here we had the equation for finding the midpoint. Now we add this column to the table and calculate the midpoints of all the rows. In the first one, 6 multiplied by minus 4 plus 136.5 equals to 112.5. Similarly we perform for all. Next we divide each frequency with its midpoint x, and then take the summation of frequency and f over x. Now just use the harmonic mean formula for grouped data. Hum equals to the total frequency 80 over summation of f over xt, that is 0.5944. Thus the answer is 134.6. Question 3.25. Salman obtained the following marks in a certain examination. Find the weighted mean if weights 4, 3, 3, 2, and 2, respectively, are allotted to the subjects. Remember weighted mean. If not, recap lecture 3.2. Okay, so we know that subject, their marks and their weightage. So, our step 1 is just to multiply weight w and the marks x of each subject. Then we take the summation of marks as well as the wx. Sigma wx is 10, 16 and sigma w is 14. Step 3. Apply the weighted mean formula. Sigma wx over sigma w, that is equal to 10, 16 over 14. And thus the weighted mean is 72.57. Next is question 3.26. Calculate weighted mean for the following items: food, rent, clothing, fuel and lights and other items. So here we create a table to calculate the weighted mean. So step 1 is to calculate the wx, i.e. multiply the weights with the expenditure for each item. Like for food 290 multiplied by 7.5. Step 2. Find the total of wx and w. The summation of wx is 2542.5 and summation of w is 12.5. And lastly, apply weighted mean formula. So we do sigma wx is 2542.5 over sigma w, which is 12.5. Thus the weighted mean is 203.4. Now, moving on to question 3.27. For a certain distribution, if sigma brackets x minus 15 is equal to 5, sigma brackets x minus 18 is equal to 0, and sigma brackets x minus 211 is equal to minus 21. What is the value of the arithmetic mean and why? Okay, we know that sigma brackets y minus y bar is equal to sigma y minus ny bar. So first, let's look into this equation first. Sigma whole brackets x minus 18 is 0, so we can write it like this: sigma x minus 18n is equal to 0, right? Now, take the minus 18n to the other side of the equation. So sigma x is equal to 18n. Then sigma x over n is equal to 18. Now, notice something interesting? That is, we have achieved the formula of the arithmetic mean. So here 18 is the arithmetic mean. Next is question 3.28. The arithmetic mean of 15 values is 20, and by adding 3 more values, the mean remains 20. Find the new 3 values if the ratio is the ratio of A to B to C is the same as the ratio of 3 to 2 to 1. First comes first, we know that the arithmetic mean x bar is 20 of 15 values, n. Now by adding 3 more values, n becomes 18, but as said mean x bar remains 20. So first we will using the arithmetic mean formula and place in the given values. X bar is 20, equal to summation x over n, 15, cross multiply. We get summation x equal to 20 multiplied by 15, that is 300, and do the same for the after values and we get summation x equals to 360. Now, we know that the total of the 3 values is 360 minus 300, which is 60, and we know the ratio of these variables. Now, we can divide the 60 according to the ratio of each variable. Thus the ratio of A, B and C is equal to the ratio of 30, 20 and 10, which ultimately is equal to the total 60. I hope you got it. Finally we have question 3.30. What type of averages would you prefer to average the following? Part 1. Marks obtained in an examination is calculated by arithmetic mean. Part 2. Growth rate of the population of different cities, as we have studied, is geometric mean. Next is part 3. Height of students. Arithmetic mean. Part 4. For size of agricultural holdings, median is perfect because the data is often skewed. Part 5. Increase in salaries. Geometric mean. And lastly part 6. IQ level of students in a class. Arithmetic mean is perfect for it. That's all for today. Please give it a thumbs up and don't forget to subscribe.